like a symphony. And you and I, we got history, yeah, yeah. And when you're alone, do you say my name or you say her name? Yeah. My love, it grows with the memories like a symphony. And you and I, we got history, yeah, yeah. Wherever love flows, there is also tragedy. When we're in too deep, and you and I, we got history, yeah.
His name is John C. his name is John C. And his name is John C.
When I close my eyes, I can almost see mind work backwards just for a minute. I hold on to you before the memory's gone. I remember you. You lift my spirit. With you high is all I'm feeling. Remember how we felt alive. I remember you. You make me stronger. Can't go without it much longer. Remember, remember. I remember you. You lift my spirit. With you high is all I'm feeling. Remember how we felt alive. I remember you. You make me stronger. Can't go without it much longer.
And his name is John C. And his name is John C.
Interpretation receiver channels are channel 1 for English, 2 for Chinese, and 3 for Korean. So please set your receivers to your preferred channels. Without further ado, the results of the Note 7 tests will be presented by Mr. DJ Ko, President of Mobile Communications Business at Samsung Electronics. Mr. Ko, the floor is yours.
안녕하십니까.
Good morning.
이 자리에 참석해 주신
Thank you all
국내외
for joining us today.
감사합니다. 먼저 그동안
First of all,
고객 여러분들과
I deeply apologize to all of our customers, carriers, retail and distribution partners, and all of our business partners.
끼쳐드려 진심으로 사과드립니다. 또한 저희를 믿고
We thank you
여러분들께 깊이 감사드립니다.
for your patience and continuous
여러분들의
support.
신뢰를 다시
We
얻기
believe
위해서는
that
우선
as a first step to regain your trust, it is important to provide you with a thorough understanding of the cause behind the Galaxy Note 7 incidents and to implement a comprehensive plan to take preventative measures.
지난
With this in mind,
저희는 모든
we
역량을
have invested all our efforts and substantial resources over the past several months to analyze every aspect of the Galaxy Note 7 in order to fully investigate the issue. As promised, we will be sharing the results of our analysis today.
설명드리겠습니다. 먼저 노트 7
Let me
발생
begin
경과와
with a brief
회수 현황에 대해
background.
간략하게 말씀드리겠습니다. 작년 8월 19일
The Galaxy Note 7 launched globally on August 19th. 2 weeks later, on September the 2nd, we announced a global product replacement program.
그리고 10월 11일
The device
최종적으로
was discontinued globally on October 11th.
현재까지의 제품
Next,
회수 현황에 대해
the
말씀드리겠습니다.
current device return status.
소비자 여러분들께 판매되어
Globally, to date,
6만 대 중 현재까지 총
96% of about 3 million devices sold and activated have been returned.
이렇게 높은 제품
We are
회수율을
grateful
달성할 수
to
있도록
Note 7 owners,
협조해 주신 소비자 여러분과 통신사,
carriers,
유통거래,
retail partners, and business partners for their help to expedite this process and achieve this exceptional return
상세
rate.
분석 내용을
Before
말씀드리기
getting into the cause of the incidents, I would like to start with a quick overview of the investigation.
저희는 철저한
For the past
원인
several
규명을
months,
원점에서
we have thoroughly examined every aspect of the device to determine the cause of the incidents.
소프트웨어 등
All aspects of the device, including hardware and software and related processes such as assembly, quality assurance testing, and logistics, were all reviewed in detail.
정확한 원인 규명을 위해서
To ensure that we conducted a comprehensive investigation,
실험실에서 재현하는
we
것이
believed that the most important step was to replicate the reported incidents In order to do that, we built a large-scale charge and discharge test facility where we were able to replicate the incidents from market and complete a detailed analysis. We also retained respected independent industry expert organizations to provide objective, unbiased analysis, which they will each share in a few minutes. Now, I would like to discuss the results of Samsung's own internal investigation. Based on questions raised in the market regarding the cause of the Galaxy Note 7 incidents, we conducted a full and comprehensive investigation considering all possibilities. To determine whether the fast charging feature had any impact, we conducted tests with the fast charging feature both on and off, using both wired and wireless charging methods, and also by applying a range of voltages and currents during the fast charge process. To determine whether the water resistance feature had any impact, we conducted repeated charge and discharge tests, both with and without the back cover. To determine whether the newly introduced iris scanner had any impact, we tested to see whether an active iris scanner had a significant effect on electrical current use. We also subjected USB Type-C port to a more than 4,000 volt electrostatic discharge to check whether USB Type-C was related to the incident. In order to see whether there were any issues with software, we ran tests on a variety of preloaded and downloaded third-party apps, as well as under abnormal software conditions, to see whether there was excessive current drain on the battery. None of these tests demonstrated an abnormality or correlation to the reported incidents. We also conducted a full investigation of every aspect of the process beyond the product itself, from component quality assurance to the manufacturing and logistics handling stages, starting from receipt of the batteries through shipping of the assembled and tested complete devices. We tracked the handling of all parts and devices throughout the manufacturing and logistics process in an effort to determine whether there were any contributing factors. Although none of these tests demonstrated an abnormality or correlation to the reported incidents, we have nonetheless taken additional steps to enhance safety. We will address these additional steps in the preventative measures section in just a moment. In order to replicate the incidents observed in the field, over 700 Samsung researchers and engineers spent several months analyzing more than 200,000 fully assembled Galaxy Note 7 devices, as well as more than 30,000 Galaxy Note 7 batteries. These devices and batteries were subjected to repeated charge and discharge testing. We found that both fully assembled devices and batteries exhibited incidents at similar rates to those in the field. This indicated that the incidents were caused by the battery cell itself and proceeded to focus our investigation on the batteries.
배터리 분석 결과에 대해
Before getting into the details of the battery analysis, I would like to first explain the basic structure of a lithium-ion battery. A lithium-ion battery is arranged in layers consisting of a positive electrode, negative electrode, and a physical separator between the two electrodes. These layers are rolled into what is called a jelly roll. In general, a short circuit within the battery cell may occur when there is damage to the separator that allows the positive and negative electrodes to meet within the jelly roll.
문제가 발생한 배터리에 대한
Based on a detailed analysis of the affected batteries, both battery A from the first recall and battery B from the second recall, we identified two different factors.
A 배터리의 경우 CT 사진에서
As you can see from the CT scan of battery A units, we found that the incidents consistently occurred in the upper right corner of the jelly roll.
손의 주요 원인은
Our analysis showed the main cause for the incidents was deflections in the negative electrode. We were also able to confirm that some additional contributing factors, such as incorrect positioning of the negative electrode tip, led to a higher likelihood of incidents. When we examined battery B, we consistently found melted copper on the negative electrode area facing the positive tap, indicating a short circuit had initiated in that area of the battery.
주요 원인은 양극 탭을
Based on our analysis, the main reason for the incident in battery B was an internal short circuit as a result of abnormally high welding burrs that formed during the ultrasonic welding process to attach the positive tab. Due to the high welding burrs, penetration of the insulation tape and the separator resulted in direct contact with the negative electrode. In addition, we found a number of batteries that were missing the insulation tape. Next, each of the industry experts will share their own independent analysis, apart from us, on the Galaxy 7 issue.
독립적으로 조사를 진행하였습니다. 조사를 진행한
I would like to introduce each of the organizations.
UL은 미국의
UL is an independent safety science organization with facilities and expertise worldwide. UL conducted a detailed technical analysis of the Galaxy Note 7 to identify the cause of the issue. Exponent is a US-based engineering and scientific consulting firm providing solutions to complex technical problems.
분석을
Exponent conducted a detailed technical analysis of the product hardware, software, and the battery. And finally, TÜV Rheinland is a German-based global leader in testing, inspection, and certification services.
인증 전문 업체입니다. 튜브 라인란드는
For Samsung Electronics, TÜV Rheinland completed a factory assessment and logistic evaluation.
이제부터
Now, each of the representatives from industry expert organizations will share their findings.
Thank you very much, Mr. Ko. We will now hear from the independent expert organizations. The first to present will be Mr. Sajiv Jesudas, President of Consumer Business Unit of UL.
Please come up to the stage.
Good morning, ladies and gentlemen. I'm Sajiv Jesudas, President of the Consumer Business Unit at UL. UL is a 120 years old global independent safety science company. We serve nearly 150 markets around the world, helping bring safe products to the market. Our mission is to promote safe, sustainable, and secure living and working environments. We have deep knowledge in the science of lithium-ion batteries and have worked extensively on the science of battery safety for both the private and public sector. Our research staff includes scientists and engineers with backgrounds in material science, electrochemistry, mechanical and electrical engineering. And our research capabilities include failure forensic analysis, internal short circuit simulation, thermal electrochemical modeling, aging simulation, and several other fields. Engaged by Samsung and as an independent third-party testing organization, we conducted a series of tests on the Note 7 device and batteries. For Company A, we conducted 2 phases of tests. The first phase was a field event sample analysis, where we tore down and examined 10 damaged Note 7 devices to understand the failure mechanism and potential causes of failure. For phase 2 of Company A, we did a battery safety boundary characterization where we studied the battery failure mechanism on 110 new Company A batteries under various abuse conditions to identify potential battery safety issues. These are the key findings of phase 1 for Company A. There were signs of internal short circuit on the upper right corners of the cells from 6 of the damaged devices. And we also find internal short circuit at the upper right corner of 4 swollen cells within those damaged devices. For phase 2, we conducted a CT scan of 30 cells and did disassembly of 20 cells. We found minor anomalies such as small void, bubbles, or uneven stress. The samples also show a similar pattern of deformation on the upper corners. The upper right corner deformation appears to be deeper than those on the upper left. And finally, a teardown analysis shows repeated deformation areas on separator at the corner locations. Our assessment based on these findings for Company A batteries reflects a combination of assembly or manufacturing issues and also some issues from the battery design. Those issues from manufacturing or assembly relate to deformation at the upper corners, and those from the battery design appear to be the cause of the thin separator, which reduces the tolerance and thereby allows for larger manufacturing defects. The higher energy density of the batteries in general also could increase the severity of a battery failure. Our assessment for Company A further suggests one major failure mechanism for the likely possibility of a field incident. This was a combination of the deformation at the upper corners, the thin separator, plus the mechanical stresses due to cycling, which causes a higher damage, which causes the possibility of separator damage, leading to an internal short circuit between the aluminum and copper foil at the corners. Additional investigation is needed to understand the root cause of the deformations at the upper corners of the batteries. For Company B, the scope of project was in 3 phases. Phase 1 was a field event sample analysis where we tore down 10 damaged Note 7 devices with Company B's batteries to understand the failure mechanism and potential causes of failure. Phase 2 was a system-level compatibility characterization where we tested 40 new Note devices with Company B's batteries under various conditions to determine whether the device itself contributed to the battery failure. And phase 3 was a battery safety boundary characterization where we studied the battery failure mechanisms on 354 new Company B batteries under various abuse conditions to identify potential battery safety issues. For Company B batteries, the phase 1 key findings were signs of internal short circuit at different locations of the cells from 5 of the damaged devices. We also had signs of internal short circuit at the tab locations of the swollen cells. There were also missing insulation tape on the cathode of the swollen cells. And finally, we observed sharp edge protrusions on the tab welding spots of the swollen cells. Phase 2 had the following findings. It was clear that the Note 7 components did not increase the battery cell temperature to a level higher than the specified threshold, and that the current drain met the specifications as provided by Samsung. The maximum charging current, the maximum temperature, and the maximum cell voltage were all also within the specification with the standard adapter provided by Samsung. For phase 3 of Company B batteries, we found that the failure mode observed in the field event samples can be reproduced by UL's internal short circuit test or localized heat pad test. The flaws were readily found from 3D CT scan of some of the samples. The teardown analysis showed uneven charge status on multiple samples, signs of internal short circuit, poor alignment and inconsistent shape and dimension of tabs and insulation tapes, and finally, sharp edge of welding joints. For Company B, we found no evidence of device-level incompatibility issues that may have contributed to the failure of the Note 7 in the field. There may be multiple contributing factors related to production quality and battery design that in combination led to the failure of the Note 7 in the field. The production quality issues were missing insulation tape on the tab, which could result in a higher possibility of internal short circuit, bigger protrusion of welding joints in the tab, which could lead to a higher possibility of separator puncture and thereby an internal short circuit, and misalignment of insulation tape and/or tab, which could also increase the risk of an internal short circuit. Contributing factors from battery design were thinner separator, which could lead to a poorer protection and reduced tolerance to manufacturing defects, and higher energy density of the batteries in general, which can increase the severity of a battery failure. Our assessment further suggests that one major failure mechanism for field incidents is likely, and that is a combination of missing insulation tape and sharp edge protrusions on the tab, combined with a thin separator, with all three leading to a high possibility of an internal short circuit between the cathode tab and the anode, subsequently resulting in heating and fire. Our further conclusion is that we need additional analysis to understand the root cause of the damage to the edge or corner of the battery, which results in internal short circuit at that location. In summary, design and manufacturing issues with the batteries led to field failures of the Note 7 devices. Thank you.
네, 감사합니다. 이어서 엑스포넌트의 수석 연구원인
We are
케빈
now
화이트
going
박사가
to invite Dr. Kevin White, Principal Scientist at Exponent, to present.
To the stage, please.
Hello, I'm Dr. Kevin White, a principal scientist with Exponent and the technical lead for the work that was conducted on behalf of Samsung to determine the root cause for lithium-ion cell failures in the Note 7 device. My formal education is in electrochemistry, and I've spent the past 20 years or so studying the design, manufacture, performance, reliability, and safety of battery systems, especially those implementing lithium-ion cells. Today I'm going to share the findings of Exponent's independent analysis of two battery types that were put into service with the Samsung Note 7 device. As you know, examples of both of these battery types experienced thermal failures while they were deployed in the field, and the devices have since been recalled. It is my goal to explain the key pieces of evidence that were uncovered by the Exponent team and how this evidence was used to formulate fact-based scenarios for the two distinctly different failure modes experienced by the Note 7 batteries. Exponent was retained as an independent third party shortly after the thermal failures were reported by users in the field. The Exponent team devised and executed a suite of destructive and non-destructive tests that were applied to failed cells and devices recovered from the field, and to new unused cells and devices that were provided to Exponent by Samsung. In addition to the work that was focused on determining the issues with the lithium-ion cells, Exponent conducted an analysis of the device and accessory electronics that were related to the overall energy storage system of the Note 7. It's important to note that the proposed root causes are consistent with the data collected during this investigation, and that care was taken to adhere to generally accepted scientific and engineering principles during the conduct of this work. The path of the investigation was defined by objective measurements, assuring an independent and impartial analysis. Before we discuss our findings and conclusions, I'd like to take a minute to introduce some of the important aspects of the lithium-ion cells that we will be discussing. This type of lithium-ion cell is most often called a pouch cell. The active portions of the cell are protected by a polymer pouch that is heat-sealed. Inside the pouch, the positive electrode, the negative electrode, and the separator membrane. The separator membrane keeps the positive and negative electrodes from touching each other. Contact to the electrode assembly is provided by the electrode tabs, which are welded to the metal foils of the electrodes. The coated electrode foils and separator are long strips that are spiral wound to form the electrode assembly. For the first part of our discussion, we will focus on the negative electrodes that are in the corner of the cell closest to the negative tab. For the second part of our discussion, attention will be focused on the positive tab interface between the positive tab and the welds and the rest of the cell. Our investigation into root cause for the failure of the cells provided by manufacturer A showed that damage to the outermost windings of the negative electrode closest to the negative tab of the cell was the most likely cause for the thermal failures. This negative electrode damage was present in all of the cells that were examined by Exponent and was found in data that were collected by Samsung and made available to Exponent. Through measurement and observation, it was found that the negative electrodes were damaged because the design of the cell pouch did not provide enough room. In the CT images on the right side of this slide, there are arrows that point out the locations of the pouch. The top image is of a cell from manufacturer A. It can be seen that the curvature of the pouch causes it to come in contact with the negative electrodes, causing the electrodes to be bent over. In contrast, the bottom image is of a cell from manufacturer B, showing that the pouch extends well beyond the ends of the negative electrodes and provides enough room. Negative electrode damage like this is undesirable because it can put strain on the separator, causing separator failure and cell faulting. Or it can cause negative active material delamination that can upset the local capacity balance, resulting in plating and potential cell faulting. Cell faulting is a well-known route to the types of thermal failure that were seen in these cells. This evidence was sufficient for Samsung to trigger a recall of the devices equipped with cells from manufacturer A. As part of this initial work, Exponent was asked to perform an analysis of cells from manufacturer B because they were intended to replace the cells of manufacturer A. Through this analysis, we found that manufacturer B cells did not share the pouch design problem with the cells of manufacturer A, and that the cells available at the time of our investigation were free of other common design or manufacturing defects. Unfortunately, that is not the end of the story for manufacturer B cells. Exponent later found that a new and distinctly different manufacturing defect was present in manufacturer B cells that were manufactured after our initial investigation. The images on this slide are a graphical depiction of the positive-negative electrode arrangement at the outer wrap of the cell, and they show the two potential failure modes that could result from the electrode bending that was observed. The leftmost image depicts proper electrode geometry. The negative electrode extends past the positive electrode, the separator extends past the negative electrode, and everything is in alignment. In the center is a depiction of mechanical damage to the separator due to electrode bending that would allow contact between the positive and negative electrode, resulting in short circuit and cell heating. The rightmost image shows a scenario where electrode bending results in damage to the negative electrode coating that results in local capacity imbalance, lithium plating, short circuit, and cell heating. Based on the available data, it's not possible to determine if one failure mode is more probable or if contributions from both failure modes might be required before the occurrence of the observed failures. However, based on our knowledge of lithium plating that is severe enough to cause cell faulting, it is more likely for this failure mode to occur later in life, after many cycles. Remember that all of these failures occurred very early in the life of the device. Following the expanded recall on October 16th, Samsung asked Exponent to perform an analysis of the Note 7 devices containing cells from manufacturer B. As I mentioned previously, these new devices contain cells that were manufactured after our initial investigation of batteries A and B. Exponent's findings related to the thermal failures of cells from manufacturer B showed that manufacturing defects on the welds of the positive tab were able to bridge the space between the positive tab and the neighboring negative electrode, resulting in cell faulting and, in some instances, thermal runaway. The weld defects were related to the height of the features left behind by the ultrasonic welder used to attach the positive tab to the positive electrode current collector. The height of some of these features exceeded 80 microns, the distance from the flat surface of the positive tab to the surface of the opposing negative electrode current collector. This distance was defined by the thickness of a layer of protective tape, the separator membrane of the cell, and the thickness of the negative active material coating. In some samples that we examined, the layer of protective tape was missing, likely due to an error in the manufacturing process. In those cases, the probability of a short circuit was higher. The damage on the positive tab has a mating damage pattern on the negative electrode. This type of damage is characteristic of internal cell faulting. It can be seen that the damage pattern is closely associated with the ultrasonic welds. Further, it can be seen that the pressure within the cell was high enough that an impression of the ultrasonic weld pattern was transferred to the surface of the negative electrode. All of these observations support the notion that a short circuit can be established between a weld defect on the positive tab and the opposing negative electrode. The images on this slide show two-dimensional and three-dimensional profilimetry data for the lower set of welds on the tab that was shown in the last slide. In these data, warmer colors correspond to higher height measurements. The data shows welding defects are relatively tall and sharp. Considering the available data, we can propose a failure scenario. Poorly controlled welding creates relatively tall welding defect features. Normal swelling and contraction of the electrodes during charge and discharge forces the weld defect features into the opposing negative electrode. Short circuit between the weld defect feature on the positive tab and the copper of the negative electrode results in heating of the cell. At high states of charge, the cell heating results in thermal runaway. In addition to the analysis conducted on the cells, a team of electrical engineers at Exponent examined the electronics associated with the energy storage system of the Note 7 device. This included device-based battery management circuitry and the electronics of Samsung and several popular third-party accessories, such as travel adapters and wireless charging pads. The goal was to understand if the electronics played any role in the observed failures. This investigation concluded that the Note 7 battery system was designed with multiple levels of protection for the lithium-ion cell that met, and in some cases exceeded what is expected by the industry for a state-of-the-art device. Further, it was found that the battery protection circuitry was capable of defending the cell against operation outside of specifications in the event an accessory, Samsung or third party, experienced a failure. The important take-home message of this work is that the electronics did not contribute to the failure of either manufacturer's cells. Thank you very much for your attention.
네, 감사합니다.
Thank you very much.
네, 이어서 마지막으로 TÜV
Last
Rheinland의
but not least, we have Mr. Holger Kunz, EVP of Products from TÜV Rheinland, who will be sharing the results of their investigation of our plants in Korea, China, and Vietnam regarding the battery safety aspects of the logistics systems and assembly processes.
Good morning. My name is Holger Kunz. I'm the Executive Vice President for the Products Business Division at TÜV Rheinland. Before I present our part of this project, let me briefly introduce TÜV Rheinland to you. TÜV Rheinland has been founded as a regional tester of steam vessels in Germany over 140 years ago. Today, our international orientation and transnational work are reflected in the company in many ways. The testing of products, for example. In this area, 80% of the business is done outside of Germany, where products are manufactured, especially in Asia, where we became active in 1986. In its role as an independent third party, TÜV Rheinland tests technical systems, services, and products on behalf of companies on the basis of recognized standards, as well as national or international statutory requirements. Our industrial track record makes us a global leader in testing and certification of lithium-ion building storage systems. The German government also relies on our specific expertise for a research project in this field. Our scope of work for this project was to review specific factors relevant to battery safety in the logistics system and to detect relevant aspects affecting the safety of the Samsung battery type EB BG935 ABA. Our investigation included investigating the battery safety related to processes of the Hanoi and Gumi phone assembly lines, performing safety tests on battery samples from assembly lines, and the investigation of possible effects on the safety of the batteries after road transport from Vietnam to China, from China to Vietnam. The investigation for the factory assessment took from November 2016 to January 2017. Samsung Electronics Vietnam prepares a sub-assembly which is sent to Samsung Electronics Gumi, where final assembly, packaging, and distribution takes place. We investigated battery safety aspects of both factory lines. Inspections and the documentations were based on the International Factory Inspection Standard format CIG 023. Work processes were inspected by our factory assessment team with respect to safety. Then an additional assessment was performed by our battery safety verification expert team specific to 3 different areas: handling, touching, and storage of batteries during the process steps, sufficient and effective battery inspection procedures including dimension checks, the status and improvements of battery safety factors. The inspection of the work processes did not show a detection of relevant weakness, concerns, or any other obvious danger affecting the battery safety integrity in the factories during the assembly. About the logistics assessment. The environmental and mechanical stress during the transport from China to Vietnam was measured by preparing 2 pallets of the batteries type in original transport conditions with instruments measuring temperature, humidity, strain, the acceleration, and the geographical position. The gathered data was analyzed and test patterns were established to allow the simulation of actual transport conditions in a laboratory environment. In order to evaluate the possible maximum stress caused by high or low temperature and high or low humidity, additional test patterns were developed for any transport condition at any time and at any season of the year. After these stress simulations, the batteries were tested in 3 different test patterns. According to the relevant regulatory requirements of UN 38.3 and IEC 62133, the batteries have passed these tests. For the verification of the assembly line and logistics assessment, results we tested 500 samples of the battery type. These were drawn at 5 locations along the supply chain from China, Vietnam, and Korea. Furthermore, 150 units were drawn from the transport route China to Vietnam. The samples were tested according to the aforementioned standards. In addition, batteries with intentionally disconnected protection circuits were tested for their safety behavior by means of overcharge, short circuit, and thermal exposure. These tampered with samples showed safe behavior under the abuse conditions and in normal use environment. Those are our conclusions. Inspections and observations of processes and workstations in the Samsung mobile phone sub-assembly line in Vietnam and in the main assembly line in Korea showed no detection of weaknesses, concern, or any obvious danger affecting the battery integrity. Recommendations for further improvements were given. The investigation of possible changes in the safety behavior of the batteries after road transport between the battery manufacturer's warehouse and the sub-assembly line showed that also after elevated environmental and mechanical stress has been applied prior to the safety evaluation, the tested battery passed the relevant safety requirements. These results were confirmed by tests from sample sets drawn at various locations in the way that the tested batteries of the logistics and assembling processes between China, Vietnam, and Korea meet the safety requirements of the aforementioned international standards. Thank you.
네, 감사합니다. 지금까지
Thank you very much. We have heard from the 3 third-party organizations about their findings. As you know, these investigations were conducted independently of Samsung Electronics. Now we will hear from Mr. DJ Ko about the preventative measures.
So far, we've shared our own findings, and the industry experts have shared their analysis and findings as well. Battery usage has increased with the growing use of multimedia. And at the same time, smartphone designs have become more compact to cater to mobility. It was important to support the various multimedia and functionalities. So from the product planning stage, high battery capacity was among the most important factors. The Note 7 was designed for a much larger battery of 3,500 milliampere in a more compact form compared to previous Note models. To meet these performance needs, new designs and manufacturing technologies were used by our suppliers for the batteries for the Note 7. Ultimately, these batteries were found to be the cause of the Note 7 incidents. Nonetheless, we provided the target for the battery specifications for the innovative Note 7. And as you will see in this presentation, we are taking responsibility for our failure to ultimately identify and verify the issues arising out of battery design and manufacturing process prior to the launch of the Note 7. Samsung is committed to the highest quality and safety. We used the lessons from this investigation to improve upon our robust quality and assurance processes and establish comprehensive preventative measures. First of all, We are implementing a broad range of internal processes to ensure that product safety and quality continues to be our #1 priority. We are taking several steps to further enhance our quality assurance for every stage of product development, as well as our system for monitoring quality issues. We are building upon our existing quality assurance organization with the addition of teams that are exclusively dedicated to focus on each core component of the device, as well as the active recruitment of external expertise. Moreover, we have formed a battery advisory group by inviting experts from academic and research centers to ensure we have an objective review of device safety. The advisory group has consulted us in the Galaxy Note 7 cause analysis and will continue to work with us on a number of aspects to help ensure the safety of Samsung products. Now, here's a short messages from each advisory member.
So it's my pleasure to be a member of the Samsung Advisory Board, and I look forward to working with fellow board members, members of Samsung, and the community at large to try and work on battery safety.
Well, I think the scale of it is unprecedented. The scale of the investigation that Samsung did is unprecedented. I've never seen such a large battery of tests performed, no pun intended. They tested hundreds of thousands of cells to actually repeatedly look at what causes the failure, and I think that has led to a pretty good understanding of what it does. They've used external organizations that largely seem to confirm that, so I think it's quite unprecedented.
Yeah, the root cause analysis Samsung has been conducting, the outcome of that, the processing of doing that will have impact beyond just Samsung itself, will help the whole industry broadly to increase the safety of the battery.
We have strengthened our quality assurance processes from the component level to the assembly and shipment of devices with an enhanced 8-point battery safety check. Before the batteries are shipped to us, enhanced X-ray and random disassembly inspections are conducted at manufacturer's level. And at the same time, we also run additional X-ray and random disassembly inspections. During the assembly of a device, our safety checks include large-scale charge and discharge tests of batteries and devices to detect any issues by using special equipment, such as the rare issues that we saw with the Note 7. And once assembly is complete, we conduct intensive testing that simulates 2 weeks of continuous use across a full range of customer scenarios. In addition, we are implementing improved training programs and management procedures for everyone involved in the handling of the batteries from the component level to shipments. In addition to 8-point safety check, we have implemented multi-layer safety measures to further put safety first from the product planning stage. At the battery design layer, we have adopted and provided preventative measures to identify and address potential device safety vulnerabilities with improved safety standards for the battery. We will implement additional requirements to ensure that there is more space around the battery in order to accommodate a new bracket design to protect the battery against physical force even when a device is dropped. At the software layer, we have improved our software protection function that govern battery charging temperature, the battery charging current, and charging duration. We hope this case will serve as an opportunity to improve the safety of lithium-ion batteries, not only for us, but for the entire industry. And we will actively share the lessons we learned so that we can continue to contribute to improved safety standards. We are currently reviewing plans to share our multi-layer safety design and quality assurance processes with global standard organizations for the safer use of products by our users. Samsung has always been committed to providing meaningful innovation to our customers. It has been a challenging period for Samsung and for the customers who have trusted us to provide them with safe products. We look forward to continuing to innovate with a stronger commitment to quality assurance and safety. We are an organization that takes great pride in our ability to listen, learn, and improve. The lessons we have learned are now deeply reflected in our processes and in our culture. Today, more than ever, we are committed to earning the trust of our customers through innovation that redefines what is possible in safety, and as a gateway to unlimited possibilities and incredible new experiences. Thank you very much.
never ever find the right words, and there's no way this is real life. There's no telling you're the right girl, so I can only say that it feels right. It feels right, it feels right. Yeah, I can only say that it feels right. It feels right, it feels right. Yeah, I can only say that it feels right. Going with the gut, never had a doubt, felt like this is just a must. Put me in perspective, I'm the deepest in the cut. Everybody tuning in, but this is just for us now. We know I ain't ballin' yet, hoes wanna holler, oh no, I don't call them back. Girl, let me see you hold it down, we gon' have a blast. Cause I just wanna know what you gonna do with all of that. Ain't gotta say a word, I know what's up. You can have it all, watch me rip it off. I'll admit it, you got me feeling hella love. Even when it's going down, know that we gon' live it up. Young shot caller, always been a baller. Know that you the one, I can feel it in my heart. Yeah, I won't stop charging, we go and come harder. I can see you and I, way beyond the stars, girl. I can never ever find the right words, and there's no way this is real life. There's no telling you're the right girl, so I can only say that it feels right. It feels right, it feels right.
And his name is John C.
Everybody tuning in, but this is just for us now.
When you want to get off the darkest ground,
And his name is John C.
You should grow feathers and see this too. When you want to get off the darkest ground, but gravity pulls you straight down. When you want to get off the darkest ground, but gravity pulls you straight down. Clear sky.
And his name is John C. And his name is John C.
When you want to get off the Gravity pulls you straight down. Earth from a bird's eye view. You should grow feathers and see this too. When you want to get off the darkest ground, but gravity pulls you straight down. When you want to get off the darkest ground, gravity pulls you straight down.
And his name is John C. And his name is John C.
Here's what happened and what we've done. Samsung rapidly took action for the Galaxy Note 7 and halted production. Out of 3 million Note 7 sold, 96% have now been returned. This past fall, 700 Samsung researchers worked to replicate the issue with more than 200,000 devices and more than 30,000 batteries. We are determined to learn from this experience. Here's what we discovered. Our findings concluded that the Note 7 device failures were due to two different factors that originated in and were specific to the two different batteries. As you can see in the first instance, there was an electrode deflection and incorrect positioning of the negative electrode tip in the upper right corner of the battery. In the second occurrence, an abnormal weld spot led to an internal short circuit. Now that we've identified the problem, we have undertaken extraordinary measures to further improve our quality assurance process. We've zeroed in on areas for improvement and developed an 8-point battery safety check, including charge and discharge tests. And then we checked the internal components with X-ray scans. Technicians subject devices to extremes, inside and out. Extreme misuse, extreme weather. It's a rigorous regimen designed to reassure everyone about the safety of our devices. Our enhanced protocols go even further, beyond industry standards for quality and safety controls. It's all part of being committed to safer devices. Samsung's heritage and commitment to innovation will not stop. We will continue to put safety first and deliver the innovative experience our customers deserve. We will learn from this experience and evolve. That's what we've always done and what we'll continue to do. Samsung, committed to quality.
And his name is John C.
Receive it,